So you look up there. You look at beryllium. Beryllium's last electron would be falling in 2s2. Okay. Look, next one's 2p1. So the last electron in boron would be in 2p1. I mean, I think you guys get the point, but now the last electron of sodium would be 3s1. Silicon is 3p2. Oh, whoops. Take that back. Okay, so we have 4s2 on here. Guys, what happens after 4s? So we go back to 3d, correct? So what I want you to write up here is just n minus 1. That n minus 1 is letting you know that once you get to the d's here, you take the energy level, that's n, okay, just 4, minus 1 to get the d, right? So it's 3d. That's how we do that. This whole thing in here, you guys, is called, what we call, and we'll introduce this a little more later, is called the d blocks. These are all ending in d's in here. Now we're back to the p's, so we're back to the fourth energy level, and it's 4p3. Come back, 5s1. Now when we go to the d's, remember it's n minus 1 to tell us the energy level here, so it's going to be 4d. So we have to write 4d1 there. After 4d1, we'll just put 4d8 the next one, so you got to count 8 of them in, guys. Now you go out of it again, you're back to the fifth energy level for the p, so it's 5p4, right? Yep. After 6s, what happens? You go to f, right? So f is going to be n minus 2. So down here you write n minus 2. So we have 4f2. 4f8, and 4f14. And we have 5d5. 5d10, 6p5, and then we'll go down to 7s. After 7s, we're going to go down to, it's n minus 2 for our f's, so we have 5f5 and 5f11 that we're going to fill in. So guys, basically you're going to be able to use these to help you essentially, I guess, cheat. It's not really cheating, but you know, cheat on your electron configurations, on your noble gas configurations. So now you really don't need your cheat pyramid anymore. Now you know you can just use the periodic table. So, guys. What we're going to do next, we're going to flip it back over. We're going to do some noble gas configurations together using this method that I just taught you, or showed you. Okay. So first one we're going to do, just want to start out with something that's really really simple, easy one to start out with. We'll do sodium to start. So you can just write Na. You guys see your little squares there? It's just where you put some examples there, like the little empty square in the bottom right. So just put Na in there. And then we have Okay. So, shortcut to doing this, rather than writing out the whole electron configuration, trying to figure out where the inner electrons are and all that stuff. You look up here, see sodium. What's the noble gas from the row above sodium? Neon, perfect. So what you do is you make brackets, and you put neon in brackets. Right, because sodium has the exact same electron configuration as neon up to that point. Make sense? That's what this is telling us. This means, this literally means 1s2, 2s2, 2p6. That's what those brackets mean right now. Now, to figure out what we have left, all we do is we look up here and we see, okay, we got 3 energy level. We're in these all in this row, guys. This is called the S block, so we're 3s1. That's how you do it. Just write 3s1. Yeah. Sure. So you look at sodium. Okay. Go find the noble gas from the row above, which is neon. Okay, so you put neon in brackets right there. Now, the only thing that sodium has that neon does not have is this 3 and then S1. Okay? If we were doing magnesium, all you would have is 3s2. Okay? So let's do another relatively easy one. Let's just do phosphorus next. Let's do P. Okay? So write P down. Shh, guys, please. So we find phosphorus here, you guys. Okay? What's the noble gas from the row above phosphorus? Neon. So once again, we put neon in brackets. Now we got to write everything phosphorus has that neon does not have. So we use the method with the periodic table. So first we write 3s2. We're skipping through here. So we write 3s2. Okay. Now we're in the which part here? These are all p's, right? Everything, guys, everything in this square over here are all going to be ending in p's. So we have, it's a third energy level. We're in the p, and then we count in 1, 2, 3. So it's 3p3. All right. Here we go. Let's do lead next. Or gold. We could do gold. Yeah, sure. Let's. Yeah. Gold. No, that's one on your sheet, isn't it? Let's do lead. Okay. So we'll do lead next. PB. So, guys, we'll take a look at PB. What's the noble gas from the row above? Perfect. Xenon. Okay, now we gotta start by writing what does lead have that xenon does not. First, we look over here. We have 6s2. What comes after 6s, you guys? Right? Nope, this part of the periodic table is cut out. It should be inserted up here, right? So what do we put next? 4f14. Okay. After 4f14, we come back up. We have 5d10, right? 1, 2, 3, 4. There's 10 of them here. So 5d10. Now we're back to the 6 energy level, and we have 6p, and there's 1, 2. 6p2. All right. Guys, we're still going to do a couple more, okay? Because I have to show you, and I'm introducing you to a little bit of a weird thing that's going to happen. Guys, it's what I'm about to show you might not make perfect sense today. I'm going to try my best to explain how it works, but you just have to take me at my word for it today and just do it how I'm going to tell you to do it, okay? So we're going to do uranium next. And it's something special with ones that end in the F block. So that end in F. So any of these, this is going to apply, what I'm about to tell you is going to apply to anything down here, okay? So write uranium down right now. So U. Okay. What is the noble gas above uranium? Rn. Radon. So we write Rn on here. Now, we got to do what uranium has that radon does not have. So we start out here. What does it have? 7s2. Perfect. What comes after 7s2? And that's where we're wrong right now. Okay? And you guys are, that's why I'm telling you this right now. Something special here is happening. So we say, you guys want to say 5F4, right? Count up this bottom row. How many are in here right now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of them. Right? There's 15. So what actually happens, guys, is these first two are part of what you think? Huh? They're D's. You're right. These first two are technically up here in the D's. So it's going to go, what do you think? What D would we be being up here? Okay, we went from here. 6D. And then how many are there though? 1. So you're going to write 6D1. Now just use your periodic table, guys. What comes after 6D1 then?
5F3.
Right, 5F3. Now, guys, you're asking me now, okay, why is that Mr. Neubauer? Okay, the best answer that I have for you right now for is that that's just the way that it is, right? So that it is the way it is because that electron. Okay, because we're explaining something that's a real thing here, right? So that electron, this 6D1, that electron is going to fill that D block, and then the next electrons are going to go and fill that inner F block. Okay, if that doesn't make sense right now, you guys, it's just I'm introducing you to this. You just got to take it for what it is right now. So anytime you're ending in an F, you got to have the 6D1 or 5D1 first. Now, why did I not do that for lead? Why did I not do it for lead? It didn't matter, right? We filled the whole D block before lead, so it didn't matter. Or we filled the whole F block before lead, so it didn't matter. That's why I didn't write it in there. Because it wouldn't have made sense too, because the whole thing is full. Okay. Questions on that, you guys? Do we need to do one more like that? Let's just do it anyways. Let's do. I don't even know if I know a name of any other ones on there though. That one's up in the D block though. All right, let's just do, I don't know, 67 ER. Let's do that, or 68 ER. Okay? I don't know, Mr. Gussie, you know the name of that one? 68? Yeah, whatever, who cares, guys? It was just write ER in there, it doesn't matter, we can still do it. Yeah, I don't know the name. So we're going to write ER on there, you guys. All right, so we look. ER, what's the noble gas from the row above ER? No, not radon. Look at. Remember, it goes into right here. It's in the same row as radon. So what is it? Xenon. So we write Xe on here. All right, we got to write everything ER has that xenon does not have. So we come back down here. Now, after xenon, we go to, what is this? Shh, guys. I'm sure some people don't get this yet. So let me, just help me out, talk me through them. What is this? What comes after the xenon? 6s2. Okay. Now, We're going to drop down to the F block, you guys, but I just told you the special case. What's got to come here before the F block? No, 5D1. 5D1, right. 5D1. After 5D1, we're down in this F block and we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? We don't count this first one. This is actually in the D block. It's right here in the periodic table. Okay? So it's 4F11. Okay, guys, we have 5 minutes left right now. Do we need to do one more example? Would you like to do one more example right now? Huh? Okay. Mr. Gussie is going to pass out your homework right now. Does anybody have any questions on any part of the lecture from today? Yes, Riley. Yes. Okay, guys. Riley's got a great question, you guys. Hold on. Shh. She wants to know about the n-1, n-2. The n is referring to the energy level, okay? So the point is that once we get down to here, we are now in what we call the fourth energy level, okay? And it's the 4s2. The reason we say the n-1 is because now it's just to remind you that when you get to the d's, you need to take the energy level minus 1 will tell you where it is, like the d energy level. Does that make sense? It tells you that you're going to get 3 then. That you're going to be 3d. You know what I mean? Here, let me just show you.